Hello, so let us look at some midterm review questions starting from number 26. So number 26 says find all roots of the equation. So then what are we going to do? We can subtract 2 from both sides over here. Then we will end up getting something like this. 2x squared minus 3x minus 2 equal to 0. Now, then we have a couple of different ways of doing it. One way which we can do it is by factoring, and another one would have been completing the square or quadratic formula. So now in this case, I realized that I was able to factor this one. So let's see. Which two numbers multiply to negative 2 and then add up to negative 3 along with 2 in the front? You see, what we can do is 2x times x, okay. That makes 2x squared, and then which negative 1 and 2, or negative 2 and 1, can be placed so that we can get negative 3x. In fact, it would have been this way. So 2x plus 1 times x minus 2 would have been equal to 0. And that would have been factored form of the 2x squared minus 3x minus 2. Then here we have, for the first factor, 2x plus 1 is equal to 0. Then we get to realize that x equals negative 1/2. Alright, how about the second one? You can see that x can be equal to 2 right away. So we have both answers right over here. Good. Now, how about number 27? We want to do this one by completing the square. How can we complete the square? It's always nice if you have to put the variables on one side and the numbers on the other. And our second step would have been this. Since we have 3 in front of x squared, how can we get rid of 3? It will make completing the square far easier. So we're going to divide everything by 3. Then we have x squared minus 2x is equal to negative 5. Now here comes our algorithm. Which number do we need to add to complete this perfect square on the left side? The algorithm is look at the number in front of x and divide it by 2, and then square that. Now that means if you divide negative 2 by 2, we get negative 1. So when you square negative 1, it becomes positive 1. So when you add, then when you add 1 to both sides, then we end up getting x minus 1 square. You see, this factors into x minus 1 square, which is equal to negative 4. Now, in order for you to get rid of the square, undo the square, we end up getting x minus 1, here comes the important part, plus or minus square root of negative 4. Alright, then in this case, square root of negative 4 becomes 2i, as you know. Then we end up having plus or minus 2i. Then the value of x would have been equal to 1 plus or minus 2i, because we have to add 1 to both sides. Alright, let's move on to the next question. Number 28. Describe the roots. When they say describe the root, then we have to use a discriminant. Do you guys remember the value of the discriminant and its characteristics? If you don't, please take your time to review them and then continue to follow this one. We realize that discriminant is b squared minus 4ac. Alright, so let's try to look at first one. What is b? B is the value in front of x, which was negative 3. So that's why I wrote down negative 3 squared minus 4. What's my a? A is equal to 2 over here. And then what's my c? C is equal to 4. So when I evaluate that, I get to realize that that's, in fact, 9 minus 32. What's 9 minus 32? That's less than 0. So if you remember, one of our conditions is if the discriminant is less than 0, when it's negative, then we'll end up getting roots that are imaginary and unequal. Now let's talk about b. In order for us to evaluate this one, what we need to do is we need to subtract 6 from both sides so that we can have an equation equal to 0. Now, then once again, we're going to apply the discriminant, which is b squared minus 4ac. What's the value of b? That's negative 1. Minus 4a is equal to 1/3. C is equal to negative 6. Now, then in this case, if you have to evaluate this one, negative 1 squared becomes positive 1. Negative negative becomes positive 6. So we end up getting 1 plus 8. Okay, which becomes 9. Then what does that mean? 9 is greater than 0. So we're going to get real value. But the thing is, 9 is a perfect square as well. So we will end up getting rational. So real, rational, and unequal would have been our answer. Okay, let's go for part C. Here, we have to add 9 to both sides, so that we can have quadratic equation equal to 0. Now, then, what's my b value? B value is equal to negative 6. So, when I square that, minus 4, a is equal to 1, and c is equal to 9. Now, let's try to calculate that together, and then see what happens. Then, negative 6 squared becomes 36, and minus 36 equal to 0. So we get real, rational. But when the discriminant is equal to 0, we know that it will be equal root. Alright, so now let's go for number 29. Find the sum and product of the root. Okay, how do you find the sum and the product? Do we actually have to find the values of x? No. We have the values. We have a formula for that, right? What is the sum of the root? In fact, that's equal to negative b over a. How about the product of the root? That was c over a. All right. So we're going to apply that to figure out the sum and product right away. So for sum, negative sign was already there. And then b was negative 6, so negative of negative 6 will be our numerator. And then denominator becomes a, which is equal to 2. So then what do we end up getting? We get 6 over 2, which is equal to 3. How about the product? Product becomes c over a, which is equal to 10 over 2, which is equal to 5. That's it. Please remember the formula for sum and product of the roots. It will make your calculation much easier. Alright, let's go for the next one. Number 30. So here we have two roots. If you know the two roots, how would you be able to find out the original equation? Now, we will be in fact using the sum and the product of the roots. Because what is our sum? Sum is equal to 3 plus radical 2, and then 3 minus radical 2, we have to add them up together. Then you get to see that that will be equal to 6. Because positive and negative radical 2's cancels out. How about the product? Then as I'm writing this one, as you know, we have to distribute the 3 and then radical 2. So 3 times 3 becomes 9. 3 times negative radical 2 becomes negative 3 radical 2. Now, let us distribute radical 2 here. Then we get positive 3 radical 2. And then positive radical 2 times negative radical 2 becomes negative 2. So as you can see, the middle terms cancels out. We get 9 minus 2, which is equal to 7. Now, how does these two numbers help? Because remember sum and the product of the root, sum was negative b over a, and product was c over a. So if we say a is equal to 1, okay, in that case, because we could have multiple different ways of writing it, if a is equal to a is equal to 1, then sum simply becomes negative b. In other words, it should have been negative b over a, but a is equal to 1, so negative b would have been the only one that's left. And then product now becomes c. Now that means whatever I got as a sum would be negation of b, as you can see over here. Whatever I got a product, that is in fact equal to c. So then our equation would have been x squared to have coefficient of coefficient a as 1, then we end up getting x squared. And since our sum was 6, then negation of 6 becomes negative 6x. And product was equal to 7, so our value of c would have been equal to simply 7 equal to 0. And that becomes my answer for question number 30. All right, let's look at number 31. In order for us to solve these inequalities and then express the solution in the set builder notation. So then let us try to do this one at a time. First, what I like to do is this. I like to isolate the absolute value by itself. All right, when you isolate the absolute value by itself, we're going to subtract 4 from both sides. Now, as you subtract 4, we get to realize that absolute value of 3m minus 6 must be greater than or equal to 18. Now, to solve this inequality, let us consider the equation, because that will give us the boundaries. Then, in this case, as you can see, 3m minus 6 will be equal to 18. And 3m minus 6 would have been equal to negative 18. We have two different cases. So for the first case, by adding 6, we get 3m must be equal to 24. And as you divide by 3, m is equal to 8. Now, second, when you add 6, then 3m must be equal to negative 12. Now, when you divide by 3, we get to see that m must be equal to negative 4. Now, what does that mean? Then, I will be using those two numbers, 8 and negative 4, as my boundaries on a number line. So, let us try to draw a number line here. Alright, and then we get negative 4, 8, and then we're going to plug in the numbers to the original inequality to see which one of them works. Now, what if I had to plug in something less than negative 4? What if x were to be equal to negative 5? When you put that in place of, or m is equal to rather, m is equal to negative 5, then we get 3 times negative 5 minus 6 of the absolute value plus 4. Now, then we get 3 times negative 5 is equal to, that's right, negative 15. So here we get negative 15 minus 6 of the absolute value plus 4 is what we end up getting after. And later, then we get absolute value of negative 21 plus 4, but absolute value of negative 21, in fact, is equal to 21 plus 4, which is equal to 25. Now, you tell me, is 25 greater than or equal to 22? Yes, it is. So we know that this portion works. Let's plug in the number in between negative 4 and 0, such as, what if m was equal to 0? Then you can easily see that 3m would have canceled out because 3 times 0 becomes 0. And we have absolute value of negative 6 plus 4 is left. Then we know that that's equal to 6 plus 4, which simplifies into 10. But that is, in fact, is that greater than or equal to 22? Nope, it doesn't. Oh, it's not. So therefore, the middle section wouldn't work. Now, for the last section, if you want to pick a number that's greater than 8, such as maybe m is equal to 10, after you calculate, you will realize that it will work as well. So therefore, on a number line, we know that our answer will be greater than 8 or equal to 8 because of the sign, inequality sign, or less than negative 4 or equal to negative 4. So we have two kinds. Then how are we going to set up, how are we going to write it up in a separate notation? Our answer will be set of values of m such that m has to be less than or equal to negative 4, or m has to be greater than or equal to 8. So that becomes our answer for this question. All right, let's look at number 32. We have quadratic inequality. How do you do that? Quadratic inequality, I'm going to subtract 6 so that I can compare to 0. X squared minus x minus 6 is greater than 0. Then, just like before, we're going to consider x squared minus x minus 6 equal to 0 to find the boundaries. What are we going to get? Here, when you factor this one, we get x minus 3 and x plus 2 is equal to 0. Then my boundaries will be x being equal to 3 from the first factor and negative 2 from the second factor. Then here, negative 2 and 3 are the boundaries for my intervals. Now, one easy way for me to check up on is this: pick a number. In this case, what if I were to pick the middle section, x equals 0? Then you will realize that 0 squared minus 0 is still 0. Then is 0 greater than 6? Nope. So therefore, you know that it's not going to work out in the middle section. Since it's not going to work in the middle section, in the quadratic, then in that case, most likely, it's going to work on the other two sections. Now, what I want you to do is this. I want you to actually plug in the values in each interval and check the values just in case. And then, after all, you cannot always trust things from the internet, right? Haha. Okay. And because of the inequality sign, I have to have an open circle on the boundaries. That will be my answer, but let's put that into the set notation. So therefore, my answer here becomes set of values of x such that x has to be less than negative 2 or x is what? Greater than 3. That becomes my final answer. Alrighty. Now, how about number 33? Now, in case of number 3, we have 1 over x is less than 1. Alright, since 1 over x is less than 1, we like to subtract 1 from both sides and then compare our fraction to 0. Then when I subtract 1, then I'll be getting 1 over x minus 1 is less than 0. But what I want to do is I want to make the common one fraction, then put it over 1. Why should I multiply top and bottom by? I should multiply by x. Then what do I get? On the bottom is still x, top is 1 minus x. It's less than 0. Alright, in that case, as you know, two components of the fraction, when it's compared to 0, can be our boundaries. Either set the numerator equal to 0, that means 1 minus x can be equal to 0 because we are comparing to 0, or denominator equal to 0 because when the denominator or when the fraction is not defined, about that point, later on you will hear a word vertical asymptote. About the vertical asymptote, the fraction may not be, they may change the signs, positive versus negative. So those are our two potential points as our boundaries, and let us try to find the values of x. From the first one, I'm going to add x, then we will realize that 1 equals x. Then we have 2 points. Same way as before, we will use those 2 points and draw the number line. 0 and 1. Then let me try to plug in a number below 0. So what if I were to set x equals negative 1? When I plug in negative 1 in place of x, I'll be getting 1 over negative 1. Is that less than 1? Yeah, because 1 over negative 1 becomes negative, and negative number is always less than 1. So in fact, that is our answer. That portion is okay. How about things between 0 and 1? What if I were to let x equals 0.5? Or you can say 1/2. Either way is fine. Then we will end up getting 1 over 0.5. Is that less than 1? In fact, if you were to put it into a calculator, you will realize that 1 over 0.5 is in fact equal to 2. And you know that 2 is not less than 1. So therefore, this will not be our answer. And of course, if you have to check up on the last section, you will realize that will work as well. So our answer in this case is to the right and to the left. Now, notice one thing. Here, which value made the denominator equal to 0? It was 0 itself, wasn't it? You see, the value that makes denominator equal to 0 will never have the closed circle. Remember, the value that makes denominator equal to 0 can never be closed circle. Why? Because that number, that value will not be part of our domain, or part of that number, the fraction is not defined. So it's not part of the value which we can compare. So therefore, no matter what about 0, we will have the open circle. But the other value, the boundaries that we got from the numerator will always follow the inequality sign. Since in this case it was simply less than 1, so that's why it has to be open circle. But if it had to be less than or equal to, it would have been closed circle. So here we have our solution on a number line, but we have to express that as a set notation here. So set of values of x such that x has to be less than 0 or x has to be greater than 1. And that becomes our solution for number 33. All right, let's try to look at number 34. Now in this case, we have to do it in interval notation. Number 34 is very similar to number 32. Then here, let's try to look at it. Number 34, first I'm going to subtract x. Then we get x squared minus 8x, which is less than or equal to 0. Now then we can factor out x. X minus 8 is less than or equal to 0. Then you know that, or I could have considered the equation either way. You can see that x can be equal to 0 or 8. And those are the two numbers they will be our boundaries. So what are we going to do? Once again, draw a number line. Here's 0, and here is 8. Let us pick a number that's less than 0. What if I were to consider x equals -1? If you have to plug in -1 into the original inequality, then you will see that it becomes -1 squared and minus 7 times -1. Then you can see that we get 1 plus 7, which is equal to 8. And we are comparing that to the value x, which is that less than or equal to -1? And you know that in this case, that's not correct. On the other hand, if you have to plug in a number between 0 and 8, such as, what if x was equal to 1? Then we get 1 squared minus 7 times 1. We'll end up getting 1 minus 7, which is -6. Is that less than or equal to 1? Yes, it is. So we know that this one works. Third portion, you can check it one more time, but you will realize that third interval will resemble same thing as the first interval here. So our answer would have been this one in the middle. Now, because of the we are looking at inequality that's less than or equal to, so our endpoints would have been circled, closed circle. So then our solution in set notation would have been 0 through 8. But since we are including the endpoints, we have to use the hard bracket or square bracket and write down the endpoints of the interval 0, 8, such as this one. All right, so we're going to stop here for now, and I'll see you later for the rest of the solution. Bye-bye.